So the next problem is 6.43, and here I drew a little pitot tube where the two inlets are going to be at point 1 and point 2. Right there in red we have the different water levels, and we know from our past problems that the variation in the height of those water levels is going to be the delta of the pressure, so at point 1 and point 2 is equal to density of our fluid, which is going to be water, times GH. Now the next thing we're going to do is that as we're moving forward in this pitot tube, we will have a streamline that goes to point 1 and also point 2. The next part is to write Bernoulli's equation for the streamline. So we have pressure 1 is equal to 1/2 rho V1 squared plus rho GH1 is equal to P2 plus 1/2 rho V2 squared plus rho GH2. So in this pitot tube, we won't have any variation in height, which means H1 and H2 will cancel out. And also at point 2, we do not have any kinetic energy. It will all be converted into that pressure at P2, which means V2 is equal to 0. And this means we could write the variation of pressure as being 1/2 rho V1 squared. Now it's important to know that this rho is going to be the density of air, whereas the rho that we're using to measure this inside this pitot tube is going to be water. So one thing important to keep note of. And as those variation pressures should be the same, we can now just put them equal to each other and solve for the height of the water in the pitot tube.